So we just finished talking about some of the people, some of the men, who are involved in getting the idea of what's going on within this atom. And we stopped with Heisenberg and de Broglie, who said that basically you can't pinpoint exactly where an electron is at a given time. It's more like a blurry cloud. But they did realize that what Bohr was saying was right, that the most likely place to find it was in the orbitals he proposed. So that's what we call the probability. The probability of finding an electron in an atom can be seen as a blurry cloud, okay, which we call electron density. And this isn't density like mass over volume. This is density like population density, like where there's more people living. More people living in a big city than out on a rural farm. So high probability of finding electrons where there's more electrons, which will be in those orbits that Bohr said, and we're going to call that high electron density. Just like in the city, we have a high population, so we have a high human density. Low probability is where you're not really going to find an electron. They realize that's between Bohr's orbits there. So that's where you're going to have a low electron density. It's possible to find one there, but it's not very probable. Now, these orbitals all have different shapes. An orbital is basically just the likely path or the region around the nucleus where an electron with a given energy is likely to be found. We have 4 different shapes, like I said. We have the sphere. I'm just going to draw a circle because, well, it's two-dimensional. We have the P shape, which is more like a dumbbell. Let's draw a figure 8 because I'm that artistic. The D shape, which is 4-lobe. Looks like a clover, really. And the F shape, which we can't really draw, and you'll see why when we go into the real looking at it on the internet and seeing what they really look like three-dimensionally. Now, each level has one F shape. And each shape can actually hold 2 electrons because if they spin in opposite directions, they don't repel each other. Normally, you think like charges will repel each other. They don't want to be near each other. But if they spin in opposite directions, they can tolerate 2 electrons in every shape. Each level has 3 P shapes, so it can hold 6 electrons in the P shapes. So 6 electrons are going to be orbiting in kind of a figure 8 around the nucleus. The D can have 5, get 1, 3, 5. So that can have a total of 10 electrons. And the F's, there are 7 of those, so it can hold a total of 14. Okay, so like I said, the electrons spin. They spin, it creates like a magnetic field. So if it spins clockwise, it's going to behave like a magnet going north. And if it's counterclockwise, it behaves like a tiny magnet pointing down. So when we actually draw them, we'll have an electron pointing up, electron pointing down to signify which way they're spinning. Okay. Now there are 3 more principles we want to learn before we get into the electron configurations, and these are nice and quick, but we're going to be using them when we do the rest of this. The alpha principle said that electrons are added one at a time to the lowest energy level first. Okay, just like if you were to take a seat, let's say in the auditorium, you're going to pick the seat closest to you before you go all the way down and pick one way at the end. Okay, you're going to use the least amount of energy possible. That's what they're doing. They're going to go to the lowest energy level. They don't want to exert anything extra. They just want to sit somewhere in their ground state and be relaxed. Pauli exclusion principle said that an orbital can hold up to 2 electrons, which is what we just talked about, as long as they spin in opposite directions. It's called opposite. Sorry. It's called the Pauli exclusion principle because it excludes anything more than 2. Hund's rule says that electrons occupy equal energy orbitals so that a maximum number of unpaired will result. So if you're sitting on a bus, and, well, no, you're not on the bus. So you get onto an empty bus, you're going to sit in a seat. Somebody else gets on an empty bus. They're not going to sit right next to you. That's kind of awkward. They're going to get their own seat. Okay, then the next person comes on. Everybody's going to get their own seat until they have to start doubling up. That's what Hund's rule says. You're not going to double up until you have to. Let's say you move into a new house. You have 3 siblings. There's 4 kids all together and your parents. And you move into a 3-bedroom house. Okay, your parents get their bedroom. So you now have 2 bedrooms to share amongst your siblings. Okay, so you get your own room because you're the oldest. The next person gets their own room. But when the 3rd kid comes around, you guys start doubling up. Okay, so that's how Hund's rule is. Everybody gets their own until you have to start doubling up. Okay,